All right, this is self-check 1.2. Again, we were given 10 minutes to complete all 5 of these problems, and now we're going over it. All right, so 1.2, number 1. Who wants to solve it for us? What are we doing?
I got this wrong.
Walk me through the process.
Because I was thinking this is the top bottom.
Top bottom?
It's not x equals infinity, so you can't do it.
Exactly. Okay, so I'm going to repeat what Isabel just said. You can only use top-bottom rules when you have limit as x goes to infinity. This is going to a point, so you can't use top-bottom rules. So I'm going to...
plugged in 0.
That's the correct first step, Isabel. You plug in 0. Can't use top-bottom rules. The correct first step is to plug in 0. You just plug it in, right? So when I plug it in, I get what? 0 over 0. Whenever I get 0 over 0, every single time, the 3 steps are factor, cancel, and plug in. Good job, yeah.
Yeah, I feel like I need to go over like a factoring thing because I suck at it, and every time I just freak out.
All right, so maybe you can come in before or after school to do that?
Tomorrow, maybe? Can I just like get
Yes, please do. All right, so I'm going to factor, well, I'm not going to factor this for you. Someone else factor this for me. What do I do?
Well, that's kind of where I got confused.
What's the greatest common factor on the numerator?
X squared?
It is. So I factor out an x squared. So what's left on the inside after I take away all the x squareds?
6x cubed.
No. On the numerator?
Oh, sorry.
X squared.
Plus 2. Perfect. Denominator. Greatest common factor is
X squared.
x squared again. On the inside I have
X cubed plus.
Oops.
6x cubed
6x cubed
plus 5x. 5.
plus 5. Perfect. All right, step 2. Cancel. So I'm going to go ahead and cancel this out. Maybe we can color code this a little bit. Cancel. And now our new thing that we have, remember I should always be rewriting limits just to get the practice, x equals 0, because on free response you do need to write this. This is now equal to the limit as x goes to 0 of 3x squared plus 2, all divided by 6x cubed plus 5. And step 3 is
plug in again.
plug in again.
So 0 again?
Yep, so when I plug in 0 into x,
Oh.
that goes away, that goes away. I should have used black. I need to color code this. I plug in 0 again. This goes away, this goes away. They both turn into zeros.
2 over 5.
And the answer here is 2 over 5. All right.
Yeah, it just needs to do a factoring.
We get out of here at 11:02, so the next few slides I'm going to go through really, really fast. I apologize.
What time is it?
It's 11:55. We get out at 11:02. All right, the graph of the function f is shown in the figure above. Which of the following statements about f is true? All right, so a is a, I'm just going to have to give it to you. I would love to ask questions, but I'm going through this fast. This is a double-sided limit. I'm going to write it down here. Double-sided limit of a, that's left is equal to 2, right is equal to 2. So this whole thing is equal to 2. Double-sided limit of b, the right is 1, left is 2. These are not equal to each other, so this does not exist. So it can't be a. 2 cannot be d and e. Double-sided limit of a is, we figured that out, is 2, because left and right are 2, so this whole thing of value is 2. 2 equals 2. That is true. The correct answer is b. Going through all the ones that are wrong. Double-sided limit of b, or remember we just found out that's d and e, because the right is equal to 1, left is equal to 2. In order,
Why is it B?
it's b because the double-sided limit of a does exist, and it is 2 because the left and the right are both going to the same height of 2.
Okay.
So double-sided limit of b, again, this does not exist, so it cannot be anything. So that's not, it's not d, it's not c, and double-sided limit of f of a does not exist. We just proved it does exist because the left equals right, and both of those happen to be 2 equals 2. So the answer was 2. It does exist, so it's not e. The correct answer is b. All right, moving on.
Wait, so why does the limit of b not exist?
The limit of b does not exist right here because the left does not equal the right. The left is equal to 2, the right is equal to 1.
Oh, okay. And then if the double-sided limit came. Okay.
Yes, double-sided limit, just another one. All right, 3, 2, 1, moving on. Okay. So number 3, limit as x goes to infinity. What type of asymptote is this trying to find? 3, 2, 1. Horizontal, good job. Yes, Isabel, it is horizontal. So we're looking at the horizontal, and we have our top bottom rules whenever we're doing that. In our top bottom rules, all we're doing is looking to see if the top or bottom is bigger. Which case is this? This is what? This is the bottom. B-O-T-T-O-M. And this is always, 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 Isabel has it 0. I think that was Isabel, right?
Yeah.
Good job. It is 0. That's an O, but it should be 0. All right. Okay, questions?
No.
I can slow down just a little bit if you need it.
No.
No? Okay. Number 4. For what values of k is a function this continues at x equals 5? Okay, what is the first thing I do? Immediately when I see this, I do what?
Solve for the left-hand suspect.
Yes, solve for the left-hand suspect point. So plug in, this is called the suspect point. Plug it in and set both sides equal to each other. So there are 2 steps here. Plug in suspect point. And step 2, set left equal to right. And I guess technically there's a step 3, solve. Here we go. Plug in suspect point. So 2 times 5 squared minus 5 times 5 minus 4. That's the left. And I'm going to set it equal to the right. So k times plugging in our 5 squared plus 5. All right, so 5 squared is 25. So this is 50 minus 25 minus 4 is equal to 25k plus 5. From here, this is 25 minus 4, so that's going to be 21 is equal to 25k plus 5. Minus 5 from both sides, and I get 16 is equal to 25k. Divide both sides by 25, and I get k is equal to 16 over 25. Answer is C.
Wait, so can you like square root the whole thing and get 4 over 5? Or they're just trying to trick you?
Can you square root the whole thing to get 4 over 5?
Like,
No, okay, I see that you, okay, you're seeing that this is a perfect square on the top, perfect square on the bottom.
Yeah.
If you needed to square root it, then you could simplify it, but you don't square root it. You just leave it like that. Unless somehow I had a k squared here, and then you would square root it. But for now,
I was wondering because it has 4
Yeah.
as one of the answers.
I don't know how, I guess
What if
maybe
it
it's
asks for,
guessing
like,
that.
The simplest answer.
If it's asking for the most simplified answer, that is the most simplified answer. Because they don't have any common factors. 16 over 25 is the final simplified answer.
Okay.
Okay. Number 5 is where I need the most.
All right, so we have 2 minutes to get through number 5. Here we go. Okay, for negative 2, so for x, all x's between negative 2, but look at this, not including negative 2.
Oh my gosh.
Wait, what?
It's not including negative 2 and it's not including 2. So most people would say, hey, look, it's not differentiable. F prime cannot exist at 2. It doesn't even care. I'm not including 2.
So if it
Oh,
was
I get
less
it.
than or equal to that, then it would.
Then it would include it, exactly. If there was a less than or equal to, then it would include it, but it does not. So it does not include negative 2 or 2. So obviously, F prime, D and E, for what? There's 4 things. Go ahead and name them.
Endpoints,
End points.
sharp corners,
Sharp quarters.
Sharp corners.
Breaks.
Ooh, that's part of a category.
VA. Oh wait. Dis.
Vertical
Continuities.
asymptote is part of, yeah, discontinuities. So I'm just going to, we're low on time. Normally I would ask you all the 4 types of discontinuities, but I'm not. And last but not least,
holes,
nope, that's part of discontinuities. Holes,
gaps.
nope, part of discontinuities.
Or something tangent.
Vertical tangent, you got it.
Yes.
Good job. Vertical tangent. Those are the 4 things. So you're looking for those 4 things. Most of these, actually all of these are discontinuities. There is one sharp corner, but it's not included. So discontinuity there, discontinuity here, discontinuity here. That's a vertical asymptote. This is a gap. That's a hole. So I'll label these 2. Hole, gap, VA. So the correct answer here is D. All right, and we have 5 seconds left. Any other questions?
Oh, okay, I see.
Wait, so how,
Wait, explain it.
how is it a hole?
How is this a hole? Because it suddenly just isn't there at this point, but it is somewhere else, or it could not be somewhere else. It just happens to not be here anymore. That's a hole. A gap is where
Those circles are actually holes?
those circles are holes. This is a hole. It's an open point. And this is a gap and not a hole because there's this giant space in between them. They don't actually connect to the same hole.
Open point is a hole.
Open point is a hole, yeah. You don't really need to know whole on the AP test. I believe you're just going to call that a discontinuity, and it just applies to all of them.
Yeah.
All right. Any final questions? I know you have to your next class to get
Can you
to.
tell us the 4 types of discontinuities?
4 type of discontinuities:
Holes,
hole, gap,
breaks,
breaks, not endpoints,
I mean,
vertical asymptotes. So these are this type of discontinuities.
okay. Do we have any?
You have no homework. Go ahead and review these and make sure that you understand them though. Tomorrow we're going to do 2 more. All right, that ends this recording as well.